In this video, we'll be calculating the derivation of centripetal acceleration, or how do we find out the magnitude of the centripetal acceleration in a circular motion. And I'm going to use a very simple mathematical or trigonometric ways of calculating the magnitude of the centripetal acceleration. So let's start with this picture here. So here is an object A at point A, and it moves in a circle in a clockwise direction, and it is moving with a uniform speed, the velocity. Here, as I said, the uniform speed. At each point, the magnitude of the velocity is exactly the same. But as it is moving in a circle, the direction is changing. At point A, the direction is at this tangent direction, and at point B, this is in this direction, and these two are completely different direction. So the direction is continuously changing, but the magnitude of the velocity, which is the speed, remains exactly the same. As the direction continuously changing, there must be a force acting on it, or there must be an acceleration, because the way we defined acceleration is the change in velocity. And remember, the velocity is a vector quantity. A vector quantity has both magnitude and direction. And in this particular example, the magnitude remains the same. The only thing that is changing is the acceleration. So this also means without acceleration or without a force, no object in the universe can change the direction. Or in other words, if the direction is changing, there must be a force acting on it. Without a force, nothing in the universe can change the direction by itself. And we'll come to that point later. So my goal is to find out what is the magnitude of the centripetal acceleration. So we assume the position of the particle at point A, and this is the direction, and after a certain time, delta t, the particle or the object comes to the point B. And we have chosen a coordinate system which is symmetric with respect to point A, or which is halfway between point A and point B. So if I choose the coordinate system halfway, then this will be our origin. This is my x-axis, this is my y-axis. Okay? And we also assume this angle is theta, and this angle will also be theta, because we have chosen the coordinate system halfway. So this angle and this angle is exactly theta now. What is the acceleration? As I mentioned, acceleration is the change in velocity. So in order to simplify it, first thing what we're going to do, we're going to resolve this velocity into two components. So here it is. So as this angle is theta, this angle will also be theta. How do we know that? It's a simple thing. So the one way is, if this angle is theta, this is 90 degree, this will be 90 minus theta. So this is angle theta. This component will be, the horizontal component will be v cosine theta, and the vertical component will be v sine theta. And here this component is v cosine theta, and the vertical component, in this case it is downward, will be v sine theta. So first let's find out what is the change in the velocity along x-axis, or along x direction. So along the x direction, the way we define the change in velocity is the final velocity minus initial velocity. The final velocity along x-axis is v cosine theta, and the initial velocity along x-axis is again v cosine theta. So there is no change in velocity. It's like the horizontal component or the x component remains the same. It's not changing even after a certain time. So the velocity component along x-axis, remember this is along x axis is 0. Now what is the change in velocity along y-axis? So the final velocity is v sine theta, and I am assuming this is to be positive direction, and the final velocity is along the upward direction, which is negative. So v sine theta minus v sine theta, and the reason we put the negative sign here because this direction and this direction are opposite. So the change in the velocity will be 2v sine theta. That's the change in velocity. And now let's find out how long does it take to reach from point A to point B if it is moving with a uniform speed v. The way we can find out the time is the length of this arc. Length of this arc divided by the speed v, because it is moving with a uniform speed, so there is no tangential acceleration. So that we can find out this time by length, or we call the distance, divided by the velocity, the speed. So the length of arc, this arc here. What is the length of this arc? For those who have taken the calculus class or the trigonometry class, should be very familiar with this equation. Theta, this equals to L over R, this equation, and this L is the arc length. So the L should be equal to R times theta, the radius times the angle, So I'm going to use this equation now. So the length of arc, so L equals to R theta, so this is R, and theta is the angle made by this arc. In this case, the angle made by this arc at the center is theta plus theta, which is 2 theta. So R times 2 theta, or what we can call, this is the change in the angle, delta theta, which is 2 theta. Okay, R is this R, and in this case this theta will be 2 theta because this angle is 2 theta. So we now find out the time here too. So we can now find out first the average acceleration from point A to point B. From point A to point B, the average acceleration. What is the definition of the average acceleration? The definition of average acceleration is the change in the velocity divided by the time. So there is no change in velocity along x-axis, but there is a change in the velocity along y-axis. Okay, so the change in velocity along y-axis divided by the change in the time. And the change in velocity along y-axis is 2v sine theta, which is 2v sine theta. And this time the delta t is r 2 theta over v, which is right here. So just simplifying this one will go on the top. So if I just do the math, v times v will be v square. This r is right here, v square over r. And then here we'll have sine theta over theta, and 2 cancels out. So we have now this equation. Remember, this is the average acceleration. Now, how do we find out the instantaneous acceleration, or the acceleration at one particular point? Now assume the instantaneous acceleration is defined, the acceleration at one particular time, or if this angle theta becomes close to 0, or theta approaches 0, or the delta time tends to 0, then the average acceleration will be the instantaneous acceleration. Or if these 2 points are very, very close here, then this angle will tend towards the 0, and that will give you the instantaneous acceleration at that particular point. So that's what I'm written here. If the points A and B are very close, then the instantaneous acceleration is given by this equation. A, the delta times tends to 0, or there is a very small change in the time from point A. If if the time is not changing, or if this point A and B are very close, then the angle theta is now equals to 0. The theta approaches 0. And this average acceleration is now v squared over r sine theta over theta. And you remember, limit theta tends to 0, sine theta over theta is equal to 1. So this term will be exactly equal to 1. And we have simply this equation now, v squared over r, v squared over r. And this is the instantaneous acceleration when the particle moves in a circle. So that's the magnitude of the acceleration. Now let's talk about the direction. As you've seen that it has only the y component. In this case, the y component is along this direction. So the instantaneous acceleration at any point, remember, is always towards the center. It doesn't matter where I'm taking. If at this point, it will be again in this direction. Okay? At any point, the instantaneous acceleration is always towards the center. So now you might be thinking, if these two, let's say if I start from this point, how do you just choose the coordinate? If you choose this point and the particle is at this point, then your axis would be this way. And in this case, again, the acceleration direction would be towards this way, towards the center. It is always towards the center. So this is the one of the very elegant way of calculating the instantaneous acceleration. So this is it for how to calculate the derivation of a centripetal acceleration. Again, if you have any questions, do not hesitate to contact me. And again, if you like this video, do not forget to like, share, and subscribe the video or my channel. Thank you very much.